Welcome. This video covers the topic of creating new variables in Sas. We've talked about a couple of the common manipulations we might want to do on our columns, renaming them, giving them labels, and maybe removing some of the variables. Well, now we're going to talk about the really cool topic of adding new variables. And this is oftentimes where you can get creative and do some really neat things. We'll look at how to create variables using the data step for the most part, and then we'll also look at using a proc to do a certain type of data manipulation that we might want to do. All right, again, the major idea that we're trying to do here is I have a data set and maybe I want to create a new variable that is probably some combination of the variables that I already have in my data set. And for instance, just to do a basic example, I have this data set on pets and maybe their age and whether they're indoor or outdoor. And I'm going to create a new variable called age type that will, of course, depend on what kind of animal we have, because cats tend to live about, 15-ish years. Dogs, depending on their size, might live a little bit less. Some birds can live a really long time. And so my age type, if I'm going to try to categorize these pets into, say, old or young animals, that's going to depend on what the values of these three variables happen to be. And so we're going to look at how to create a variable, say, as a function of the previous variables already in my data set. To do this, though, we kind of need to learn a little bit more about how Sas actually works when it's running a data step. And this is going to get a little bit complicated, but let's get through it because it's going to help us understand how to create our new variables. Well, whenever you use a data step to read in your data or copy your data, Sas basically does a few things. First, it looks at the code that you wrote and checks for any errors. Hopefully we've written well-formatted code that matches the syntax that we're supposed to use for Sas. So let's kind of ignore that bit that we might get an error there. We've written good code. Now what happens? Well, the data set that we're going to either copy or read in gets read in line by line. So one line at a time. So it'll read the first line and then read the second line and then read the third line. So it loops over these rows or observations in our data set. And so Sas is going to process the first observation. So it's going to take that first row of data, whatever it happens to be, and any manipulations that you might do, say creating a new variable or whatever, are evaluated. And those are processed and added to the new data set. And then it goes to the next row, does the same thing. So Sas really only has access to the data within that row to create a new variable. So that's kind of important to know. But it's going to do this for the first observation. It's going to do it for the second observation. It's going to keep going until it reaches the last row or last observation in your data set. And so if we want to create a new variable as a function of the other variables in my data set, I can do so within my data step. And all I need to do is name the variable on the left-hand side and then and put an equal sign and then write the function of the columns that I already have in my data set on the right. That's one way to create a variable. We end that thing with a semicolon. And so we're actually going to be using a statement here, but it's not a statement that starts with a keyword. We just name the variable, equal sign, function of the other variables, end it with a semicolon. So it might look weird because most of the time when we're writing our Sas code, the keyword or whatever we do to start our statement turns blue and it makes us feel good. We lose that feel good feeling, but that's okay. Here's an example of how we might do this and how the data step is working. So the first thing we do after we've written our code here, you can see that the code is similar to what we've been doing, right? We're creating a new data set. We're copying our old one. And then we're doing some new things that we haven't done. So I'm creating two new variables here. Again, I'm just going to name the variables on the left-hand side. I'm going to put an equal sign and then put whatever function of the variables in my data set that it happens to be that I need to do. I'm going to end that with a semicolon. So I have two Sas statements in there to create two new variables. Okay, so again, what happens is Sas is first going to do an error check, make sure that this code syntactically is correct. And then it's going to start processing the copied data set row by row. So we're going to loop over our observations. We're going to read in this first row that we have over here on the left, var1, var2, and var3. And then it's going to try to create add and letter based off of those. So it's going to say, oh, add is variable 1 plus variable 3. So when I go over here and look at my add, it's taking 10 plus 30 and making 40. With letter, we're using this interesting Sas function. It's a very common way to create a new variable is use a Sas function. And this is the substring function, and this is going to grab a particular character from a character string. or characters. So here I'm saying we're going to grab the first character string, the first character in the character string and end after the first character. So we're only going to grab the first character within our character string. And so we're basically grabbing the C from cat over here. But that's what it does. It's going to read in that first line of the data set, do whatever manipulations you're asking for, and then it's going to go to the next line. It's going to read in that line, do whatever manipulations, go to the next line. And so it's going to repeat this process and hopefully not run into any errors while it's running. And there we go. That is the rough idea of how this data step works when we're trying to read in and copy data. And this is really important to know about when we're trying to create our new variables. All right, so you might ask yourself, well, what am I limited to whenever I'm thinking about creating a new variable? What kinds of things could I actually do in Sas? Well, again, you're just going to name your variable on the left side and then write the function that you want of the other columns on the right-hand side. And Sas can do any kind of math that you want. So, you think about plus, minus, multiplication, division. It can do all that. You can do exponentiation with a double star or double asterisk. There are a bunch of Sas functions that help you do other mathematical operations that you might want to do, like absolute value, square root, sum, etc. But remember, when you're thinking about doing something like sum, you can only sum the observations within that row, right? You can't sum an entire column and add that as a new variable. You can only sum the observations that Sas is currently looking at, which again are whatever rows it's copying at that particular time. So if I'm going to do the sum of something, that's essentially what I'm doing up here. I could replace this with sum var1 var3. And that's just going to take the sum of the two observations from those variables within that row. And so there's a whole list of mathematical functions in Sas that you can check out if you're interested. This website will give you all of the different ones that you might ever care to do. So that's great. Over here, I've just given a couple examples of how you might use these things. So I'm creating here 5 different variables. Just utilizing some of these mathematical functions. Okay, so math functions are one thing that you can do. And again, we've talked about this differing behavior between statements and dataset options. And this is a place where doing one versus the other can be very important. Perhaps you want to take that very small basic dataset that we did with the movie ratings, and I want to create an average rating that's the average between the rating of the critics and the rating of the actual users on the site. So I want to take the mean of ratings and stars. Well, here's my new variable name on the left. This is the function of my other variables in my data set. But if I had dropped some variables, it depends on how I drop my variable, whether or not I have access to those things. So for instance, down here, this one on the left is going to work. So if I want to create my new variable and I use a drop statement, remember that the data set gets copied over in its entirety, and then I'm going to do my manipulations and then drop the variables at the end. So even though I'm dropping votes and ratings, I can still use ratings here because it's been copied over into my data step. If I look over here on the right though, if I use my drop option, these variables are not copied. So I might want to create an average rating here, but I'm not going to be able to use the mean of the rating and stars variables because rating is not going to exist in the copied data set. So again, we do have implications between using a statement versus a data set option. Okay, what other Sas functions might we do? We've seen the mathematical functions, of course. Well, there's a lot of different functions that you might use, especially ones that are corresponding to dealing with strings, so character strings of data. So there's a whole list of them that you can access at that link. Some of the most commonly used ones would be compress, which removes characters from a string. So maybe you have some spaces in a character string and you want to remove all the spaces. You can do that. Count W will count the number of words or distinct characters within there. So if you have spaces, the number of words that you're dealing with. Scan will return a particular word. And then substring we saw will return a particular portion of a string. So these are super useful when you're trying to do some text manipulations. And so let's look at an example of using that scan function. We saw an example of substring before. This is an example of scan. Remember, scan is going to return the nth word. So with this Fandango data set that we have, within there, one of the variables is film, and this gives the name of the film. And just for the fun of it, I might want to return the first word and second word of the film title. So on the left-hand side, again, what I'm doing is I'm specifying the new variable names that I want to create. And on the right-hand side, I'm using the function of the columns that are already in my data set. And so here I'm using scan, and I'm saying scan the film variable, and then one says grab the first word. So grab the first word from that string. And then likewise for the second one, I'm doing scan film 2 to grab the second word from that string. If I look at the output of that data set, I can then see that I have two new variables, first word and second word, that are grabbing the first and second word, respectively, from our titles. One thing to note here, though, it's a little bit interesting. Down here, whenever we only have a one-word title, we do still have a year afterward in parentheses, and notice that it drops the parentheses and only grabs the numbers within there. So understanding the behavior of these functions is really important, and that's where you can go to the Sas help and figure out exactly what these things are doing. Again, there are so many Sas functions out there that are useful that you might want to think about. If there's something you want to do that's a function of just the observations within that row, you can go to this list of commonly used Sas functions and probably get a pretty good idea of what you can actually do. Now, there are really important manipulations that you might end up doing with date variables. So date variables come up quite often, and we'll look at an example of that in our video program here in a minute. But date variables are technically stored underneath as numeric variables that are the number of days since 1960, January 1st, 1960. But they have a format on top of them that make them show up in the viewer and when you print out your data in a nicer way most of the time. But since they are stored numerically underneath, you can do things like add and subtract dates and get a sort of a difference in days and things like that. Some of those common things that you might want to do with days. And so there are three major functions that you might want to use with a date variable. That would be day, which returns the day of the month, month, and year. So we'll get an example of that in just a little bit. All right, how else can I create some variables in Sas? Well, another really common way to do it is through conditional logic. When we saw that example with the cats and the animals and the ages, right, we were thinking, well, if you're a cat and you live this long, you're old. If you're a dog and you live this long, you're young. Well, that's the idea of conditional logic. If this, then that. If this, then that. And so we might want to be able to do that in Sas, and it's pretty easy to do. We just have to learn the syntax. For instance, we might have a data set where we have variable 1, and if it's less than 10, we want to set that variable to low. If it's between 10 and 20, set it to medium. And if it's greater than 20, let's set it to high. Well, we just need to learn how Sas does logical comparisons and put those within what we call if-then statements to be able to do this. So how does Sas compare things? How do I tell Sas to look at this variable and check whether it's greater than 20? Well, you can either use symbols or you can use mnemonic equivalents to symbols. So like if I want to check if something is equal in Sas, I can use an equal sign, or I could just put EQ, either way. If I want to see if something's greater than, I can use a greater than sign or GT. Greater than or equal, slightly different. Greater than or equal has a greater than and then an equal sign, or GE for greater than or equal, mnemonically. So that'll be pretty easy. We just need to remember these and have this table somewhere available for us. And then you might say, well, in that one example you said, well, if it's a cat and it's this age, I want to do something. Well, that's what we call a compound logical, where we have more than one logical condition. And so we need to make sure that we can do that in Sas. Well, if I want an and, I can either use an ampersand or the mnemonic equivalent of A and D. If I have an or comparison, so if I say if it's a cat or if it's less than 10 years old, do something, well, I can either use a vertical bar or an or sign. It's a little bit hazy which of these symbols you want to use depending on your operating system, but or should work for most operating systems. So you probably want to use the mnemonic equivalent here when you're doing ors. Same thing for nots. Let's consider that Fandango movie data set again. And this Fandango data set, maybe what I want to do with it is create a Watchlist variable. So this is a variable for myself that's going to tell me, based off of both the stars and the ratings variable, whether or not I want to put this aside as a video that I want to watch later. And so here's the conditional logic sort of just written out in words how we might try to create this variable. Well, if both stars and rating are greater than 4.4, I want to set my watch list variable to watch. Else, if that's not true, so if both of those are not greater than 4.4, I want to consider if one of these is greater than 4.4, set it to maybe. And then if none of those are true above, then I want to set that value to no. So if everybody likes the movie, both the critics and the reviewers, then I'm going to set that to watch. If at least one of them likes it more than 4.4, I'm going to set it to maybe. And if neither of them think it's good, I'm going to set it to no. And the really only other thing that we need to do is figure out how to do this if-then logic, this conditional logic in Sas. And so here's the syntax for doing that we can use within a data step. And so we're going to be focusing on what we see down here because we're doing sort of an if this, then do that, else if this, then do that. But you can see up here that you could just do an if-then, just a single line, or you could do an if-then else, just one of them. And really you can continue on as many levels of if-then else that you'd want to do. But here's the idea with this if-then logic. If this condition resolves as true, then we execute this action. So we execute whatever code is here. And that might be where we assign our new variable, right? So if both stars and rating are greater than 4.4, my new variable watchlist should be equal to watch. If that's not true, so if not true, we jump down here. So if our first condition is false, we jump down to that second line and we say, well, else, so if that first one wasn't true, else, if this condition is true, so now we have a second condition. So if that's true, evaluate this code, whatever we put here. And again, we could continue this for as many levels of if then else that we'd want to do. And one thing that we'd want to do at the end of most of these, good programming practice says, put in a catch-all case at the end, which just says, if all of the above statements, if all of the above conditions were false, then the explicit action I should do is given here. So it's just a nice way to make sure that you don't miss any cases. But we now have all of the tools we need to create a variable using this conditional logic. We know how to do conditions, we know how to do compound logicals, and then we know how to do the if then else business. So all we got to do now is put this into a data step and see what happens. So here's a data step that will allow us to do this kind of thing. Again, what we're going to do is we're going to copy our data set first. We're going to create a new data set called NCSU Watchlist. And you might notice a statement here that we didn't talk about. This is a length statement. And it's good practice when you're creating a new character variable to set the length of the variable explicitly. And the reason is that Sas, by default, character variables are of length 8. But the first time that Sas sees the variable within your declaration of your data step, it's going to assign the length of that variable. So the first time that it actually sees status here is over here. That's the first time that, as Sas would be parsing this data step code, it sees status. The value it takes on is of length 5. So Sas will automatically set it to length 5. Well, if I had a value down here, so maybe this wasn't maybe, but this was, I'm thinking about it, I want to put that in a huge quoted string, that would get truncated to only 5 spaces. Because the first time it saw status, it said, oh, this is only of length 5, so I'm only going to set this variable length to 5. So it's good to explicitly set the length of your variable to whatever the longest string it could possibly be is. And again, you can do that via a length statement. Okay, so now that's kind of out of the way. Let's jump down here to the if then else business. So again, we wanted to create this variable that you see above. So we need to have 2 conditions. We want to care both about the stars column and its value and the ratings column and its value. So if stars is bigger than 4.4 and rating is bigger than 4.4, then the code I want to do is tell status, this new variable I'm creating, to be equal to watch, a quoted string of watch. And then down here we say, well, else, if that wasn't true, if either stars is greater than 4.4 and rating is less than or equal to 4.4, or stars is less than or equal to 4.4 and rating is greater than 4.4, then set this to maybe. And you could do this line of conditional logic a little bit more simply, but I wanted to write it out completely in sort of as much detail as I could here. And then if neither of those cases are true, so if neither of those two conditions are met, we then jump down here and say, well, else just set the status to no. I don't want to watch that variable, that film. And so if we run that, we'll see our new data set has a variable called status, and I do not want to watch 50 Shades of Grey. Fair enough. All right, another thing that we should know about when we're creating variables is the idea of missing data in Sas. We've been talking for the most part about really nicely formed data sets that have all of their observations. Well, sometimes some of the values for a particular row will be missing. And that's called missing data, observations that don't have a value. And remember, Sas has only two types of columns, numeric and characters. So if you have a numeric variable that it has a missing value, in Sas that is replaced with a period. So you don't just see a blank space there, you'll see a period. That indicates that this numeric variable is missing a value in that spot. If you have a character variable that's missing a value, Sas just uses a blank space. So when you look at it, it will just look like a missing spot in, say, your proc print. And what's really useful to do when you're dealing with missing data is using the missing function. So the missing function will identify any values that are missing, whether it's character or numeric, and it will return a 1 if it's missing and a 0 if it's not. And so it's really useful for doing conditional logic and, say, creating a new variable, or what we'll see later, dropping particular rows from a data set. You might wonder what happens if I don't have these else if conditions. Well, Sas will actually assign a missing value to your variable if you don't have a condition for it. So in this case, I'm just going to create a temporary data set called temp. I'm going to say just if stars is greater than 4.4 and ratings greater than 4.4, set status to watch. But notice that I have no other conditions. So for films that don't have this condition met, I'm not assigning it a value. And so what does Sas do? It assigns missing values to those. And so again, that's really important to know about when you're dealing with creating your data, and especially when we talk about subsetting data, subsetting rows later on. All right, one other thing that we often want to do is center and scale a variable. When we're doing machine learning algorithms especially, we oftentimes want to do this. We want to take the value of the variable and put it on a scale that's sort of standardized. And so what you need to do for that oftentimes would be take the variable, subtract off the mean of all observations within that column, and then divide by the standard deviation of all the observations in that column. But remember that Sas, when we're going through our data step, does it line by line. So when you're in this particular line, you don't have access to all of the data in a particular column. So just think about a simplified version of that standardization. Maybe I just want to center my variable. I want to take the actual variable value and subtract off the mean of all of the observations in that column. In a data step, you can't really do this very easily. It's not going to work very well. For instance, here would be a case where I have this variable and I want to center it. So I want to take the value 10 and I want to subtract off the mean of all the values in this column. Well, here would be how I calculate the mean, right? This is the mean of my column. But you can see that that requires us to have access to 10, 12, and 14, all of the rows at once. Again, within a data step, we don't have access to these things. So that's a problem. We can't use the mean function like you might think, because again, mean is only going to be able to take in values from that particular observation from different variables. That's not what we want to do here. Calculation of this mean is going to be difficult in a data step. So what do we do instead? Well, with most things in Sas, if you're stuck on something, there's probably a proc that's going to help you out. And the proc that we want to focus on here is Proc Standardize. This is going to allow us to standardize variables for analysis like you might want to do. And Proc Standardize is actually pretty generic in terms of the standardization that you might want to do. And so it allows you to take any variable, so this is your original variable, and create a new variable called result. Well, you'd call it whatever you want it to. But basically you can add a constant, you can multiply by a scaled version, a centered and scaled version of that original variable. So it gives you a very general way to do a transformation of that variable. We had to learn the syntax of Proc Standardize to be able to do this. As with most procs, we're going to start with that statement that starts the step. So proc standardize, we're going to specify the data set that we want to be working with and that has the variable we want to standardize. And then we can specify an optional output data set if we don't want to copy over that one. And then we can specify what method of standardization we want to do. And I have a link here to the different methods of standardization that are available here. But usually you just want to do either mean or STD. So mean just centers the variable, just like we talked about on the previous page. STD takes both the variable and centers it, and then divides by the standard deviation to give it an overall standard deviation of 1. So we call that normalizing a variable generally. There are some other really useful things that you would put on this, useful options that you would put on your proc standardize statement. And those are O prefix and S prefix. And what these do is they allow you to keep the original variable in your data set if you want to, by just telling Sas how you want to specify the prefix on the new variable you're creating. Otherwise, it's just going to overwrite the previous variable, which generally you don't want to do. You can do a by variable statement here. So if you do a by statement, this allows you to do a standardization for every different level of some categorical variable. You do need to sort your data first if you're going to use that. And then the var statement allows you to pick which of your variables you want to do the standardization of. And of course, just like most of our proc steps, we're going to end it with a run statement. Here's a quick example. We might want to read in some data on weather. So this is a data set called chicago.csv that's available online. So we're going to pull it from a URL. We're going to read it in with proc import to our NCSU library as a data set called Chicago. You might notice one new statement here that we didn't have before, this guessing rows equal max. This data set in particular has a weird value for the PM10 column, I think. And so Sas, what it does when it uses proc import is it guesses what kind of column each column is, either numeric or character, based off of scanning the first, say, 1,000 rows or something like that. So if the first 1,000 values are all numeric, but then the 2,000th value has a character string in it by accident, so maybe it's a typo or something, that's going to throw an error, and then the import's not going to work. So if instead you put guessing rows equal max, Sas will scan the entire file and say, oh, I've looked at all the values for this particular column and what they should be, and at least one of them is character, so this entire column will now be character. If all the values are numeric, it will say, oh, then this whole entire column should now be numeric. So this is just a workaround for a little bit of non-standard data. All right, let's look at this data set before we standardize it. These are the different variables that we get. And so you might see variables like death and temp. So these are the temperature in Chicago, the number of deaths, and some other weather information as well from 1997. And maybe we want to standardize these two variables for use in some analysis. We'll use proc standardize. We're going to output to this is going to be to our working library, a temporary data set that has variables that are both centered and scaled. And notice again, I'm going to use this business over here that's going to allow me to keep the original variables and just specify how I should do the prefix for the new variables I'm creating. And so I'm saying std, I want to put std before these variable names as my new variables. So you can see that those appear down here. But we're using method standards, so this is again going to both center and scale these things. And I'm just specifying that I only want to use two variables, death and temperature here. But this gives us a way to now have standardized versions of these variables, and we couldn't do this again very easily in a data step. There are ways to do it, but they're much more complicated. Okay, so we've done a lot of examples of creating Sas variables using the data step, using this proc standardize. Let's jump into Sas and do a little bit ourselves live and see how that goes. Here we are in Sas. We'll go ahead and continue our previous program we did before, but we will use a different data set. So I'm going to just put a block comment here. This will be our creating new variable section. And there are, again, some different data sets that are available on our shared folder. So we're going to read in this cafe.xlsx file. And to do so, we'll just use proc import. Again, easiest way to get the path to this thing, just right click on it, properties. Then we can copy that location. Missed that first slash, so I'll add that in. Put that in a quoted string, specify what kind of file it is. Of course, it's an XLSX. output data set. We're going to go to NCSU, our library that we already have predefined. We'll just call this cafe data. And then get names. This does have the names associated with it. And then we'll just do run. Let's run that, make sure the data set gets read in correctly, and we'll check out what variables we have to deal with. And you can see here, one of these variables has a date. It's a date variable, and you can see that Sas actually puts a calendar next to it, so this is noting that this is a special type of variable. If I click on that, you can see that it is a numeric variable. So again, Sas only has two types of variables, numeric and character. So it's numeric, but when you look at the format changes the way that the variable is displayed. It's being displayed as a date. So underneath, this is actually being stored as a number, the number of days since 1960, January 1st, 1960, but it's being displayed much more nicely in a way that's sort of readable by us. Okay, but in this data set, we have, the day of the week, and then different information about what was sold at this cafe. All right, we might want to create some new variables, and let's just start by manipulating this date variable since we have interest in dates quite often. So we'll go down here, we'll start a data step. Let me move this up a little bit. So we have a data step. We'll just create a temporary data set called cafe in the work library. We'll set ncsu.cafe data. And we're going to create a new variable. Let's go ahead and use the year function just to see that that works. So we'll just go year equal year of date. Date is the name of the variable that we have over here. Just jump into the library, make sure we can see our variables. Helps us understand what's going on. So again, we have this date variable. Sas is not case sensitive unless you're in a character, unless you're in a string. So I can use a capital or lowercase d. I'll also just grab the month for the fun of it, and we'll just run that and see if that works. So again, on the left, these are the names of my new variables. On the right is the function of the actual columns that I have. Let's run that. Always check your log. Let's see, we have 47 observations, 12 variables. I don't see anything bad there. So let's go to our output data set. We now have a new variable called year and a new variable called month. So they should be 2010, 1112. So let's see. Scrolling over, 2010, 1122. You can see here that that did exactly what we want. So again, oftentimes we're going to want to deal with this kind of date variable, and it's important to be able to play around with these. Let's see. Next up, maybe we want to standardize a variable there just by centering it. So I can use Proc Standardize. I'm going to just grab that working data set, so the data set in our working library. And I'm going to use the method of just center. So I think that's called method mean. And I'm not going to keep the original variable in this one. So we'll just do that. And the variable I want to standardize just by subtracting off would be, let's just do the cost variable. Or let me make sure I know what these are called. Sorry, let's do the sales variable. We'll hit run. This should give me a standardized version of my sales variable. And notice again, it's going to overwrite that original variable here rather than keeping it and creating a new one because we did not do the prefix business. All right, let's just do one more thing. We'll come back up here. Notice that that variable has changed, so we have overwritten that. So if I come back up here and I start playing around and using that sales variable, it's going to be the standardized version since I've already run that down there. However, since I'm setting and copying this again, we're going to take care of that. But you do need to be careful about running code in a logical order. Once you do something down here, that's going to affect if you go back and try to run something up here. Let's create some new variables using if-then logic. So I might want to create a new variable based off of what month we are. So I might say if our month is less than or equal to 2, then let's call our season winter. And let's actually, season equal winter. Apologies. Oh, I must have insert on. Winter. But let's not put a second condition on here. So basically, if the month is not less than or equal to 2, we should have some missing data. Let's go ahead and run that and see what happens. Should always check our log. I don't see anything bad happening there. Jump over here. Okay, So now we have winter for all these first observations and then missing values down here. And again, we talked about this missing function, so let's just see a quick example of that. So we utilize missing. And so maybe we want to create a new variable that deals with, if this variable is missing, let's do something else. So data, we're going to copy that cafe data set. So we'll just set cafe. And then we'll create a new variable. Let's not call it missing. Let's say ob missing. And we'll just do missing of the variable we just created, season. And this is just to show you the functionality of this, to show you what it returns. So let me run that, create a new variable called obs missing. Again, check our log. Nothing red or green there. It's good. We go over here, and now this is an indicator telling us whether or not there's something missing from the season variable. So 0's here, 1's there. And again, you could think about how you could use this, and we'll talk about how to do it later, to say subset our rows or do something like that. So again, just a couple examples of how we can utilize creating new variables in Sas. All right, let's wrap it up. We now have all of the basic kinds of column manipulations or variable manipulations that we might want to do to our data sets. We can change the variable names. We can change the way that they show up when we print them out or run some analyses. We can remove some of our variables through drop and keep. And we also now know how to do some basic variable creation. And so we have a lot of really powerful tools at our hands now that we have this under our belt. And what we'll look at next are different things that we might want to do to the rows rather than the columns.